Hello, my great friends. IBM is here to bring you an episode of Learning Physics. Today, I'm solving paper 1 multiple choice. This is February-March 2023. The paper is 1 hour and 15 minutes. It is actually 9702112. I'll not take much time because it is a very short paper. It is just multiple choice, 40 multiple choice questions, which we can solve in a short period of time. So, let me choose a color. Let me choose purple. Okay, so without wasting time, after this paper, I will record work, energy, and power. Do not forget the paper is in the video description. You just check in the video description, get the link to downloading the paper. Then you can try to practice on a printed hard copy so that you understand the questions very well. Do not forget these papers could guide you, and if you have been watching my videos, the multiple choice questions per topic, this is going to be a very easy paper for you. So without wasting time, let's go to the multiple choice questions. So without wasting time, let's go to the multiple choice questions. This paper has a total of 40 marks. Normally, the instructions are to answer in the multiple choice answer sheet, and we just use a soft pencil. So here we'll just use a simple method of answering the questions by simply circling. So let's go to number 1. We are familiar with this formula. We are familiar with the constants. So straight away, let's go to number 1. What represents a physical quantity? Remember, in all the videos I've been recording, a physical quantity should have a numerical magnitude and a unit. So it means this has no units. This is just a unit. This one has no unit. So the physical quantity is going to be C because it has a numerical magnitude, which is a number, and a unit, which is the Newton. The relationship between the variable dt is given by the equation 1 over t is equal to b over root of d plus c. Where b and c are constants, the unit of d is meters squared and the unit of t is seconds. What are the units of b and c? Okay, so we can try to simplify this. When we try to simplify this, we shall have by cross multiplying, we'll have this side times t times t times t. So I have that 1 is equal to b over root of d times t plus c times t. Then when I cross multiply again, when I multiply by root of d again, on the left hand side I have root of d is equal to b times t. Root of d cancels here, plus ct root of d. I want you to note that we only add quantities of the same units. And the units on for homogeneity, the units on the left hand side should be the same as the units on the right hand side. Alternatively, I would even just have used I would not even have done this. There is no need for me even to do this. I can just use homogeneity straight away, that on the left hand side we have 1 over t. The units on the left hand side should going to be s power negative 1. These should be the same units on the right hand side. So, and remember, we are adding here quantities. We only add quantities with the same units. Therefore, b over root of d should also have units as per second. But they said d is in meters squared, so b over meters squared under square root should be equal to per second. That means b is going to be equal to per second times root of m squared, which is just m. So it means the units of b are going to be meters per second. So we ignore ms. We also ignore per meter per second. We ignore per meter per second, per meter seconds, per meter per second. So that is enough for us to know that the answer is B. Because the unit of C, because we add the quantities of the same unit, so it means if B over root of D is per second, then C is also per second. So the answer is going to be B. A hollow cylinder which is open at both sides. So this is a cylinder, on both sides it is open. And if it is open, these surface areas are going to be ignored. The area here would be pi r squared. If it was closed, This would also be pi r squared if it was closed, but since it is open, these surfaces are going to be ignored. It has a radius, so what we are going to do to consider is just the circumference of the cross-sectional area and this length here, or the height h, or the length, let me just call it L. So it means if we want the surface area, because the ends are open, we shall not include the areas of the cross-section, but the surface area will simply be the circumference times the length L. So the surface area will be 2 pi r times L. And this will be equal to 2 pi times r, which is 3 centimeters, then times L, which is given as 15. We check this with our calculator. 2 pi times 3 times 15 gives us 282.7. So this is 282.7. This is going to be centimeters squared because I didn't change the units of R and L. So it means we ignore D, we ignore C, we remain with A and B. Now we have to check the uncertainty. Because of multiplication and division, I will ignore this constant 2 pi and I will only deal with the uncertainties in R and L. So because I'm multiplying, I will deal with the fraction uncertainty. So the fraction uncertainty in area or in surface area is going to be, let me use S for surface area rather than A. So the fraction uncertainty in the surface area is going to be the fraction in R over R plus the fraction in L over L. That means the absolute in the surface area is going to be, for R is 0.1 over 3.0 plus for L it is 0.1 over 15.0. Then I'll multiply this by S. So this is times 282.7. So from my calculator, I have that 0.1 divided by 3 plus 0.1 divided by 15. So that is the fractional, then times the true value, which is 282.7, and this gives us 11.308. So this is 11.308. Uncertainties are good enough to one significant figure, and one significant figure to be approximately 10. So if it is 10, then S is written as, S will end with a 0, so it will be 280 plus or minus 10. So our answer is going to be B. A snooker ball of mass 0.2 kilograms has a collision so that its direction of movement changes by an angle of 90 degrees. So this is the initial direction, then the angle changes 90. I'll just bring this one here. This is going to be 0.30 meters per second. The ball has a speed of 0.4 meters per second before collision and a speed of 0.3 after the collision. What is the magnitude of the change in momentum of the snooker ball? So we are going to find momentum in the horizontal, which will be 0. Because remember, momentum is mass times velocity. So momentum in the horizontal will be the mass 0.2 times the velocity 0.4. Then momentum in the vertical, momentum changes to the vertical, so it is 0.2 times the speed, which is 0.30. So if we join it as vectors, then the resultant is here in this direction, which is going to be clockwise. The resultant is head to tail. So that one is these are at 90 degrees, so we just use Pythagoras theorem. So the change in momentum is going to be the square root of 0.2 times 0.4. This is squared plus 0.2 times 0.3. This is also squared. So we can check using a calculator. I will have 0.2 times, let me put brackets, 0.2 times 0.4, but this is squared, plus 0.2 times 0.3, this is also squared. Then I find the square root of the answer, which is going to give us 0.1. So the change in momentum is 0.1 kilograms per meter, kilogram meters per second, because it's mass times velocity. So our answer is automatically B. ball is kicked upwards at an angle of 45 degrees to the horizontal ground. After short flight, the ball returns to the ground. It may be assumed that air resistance is negligible. So if air resistance is negligible, what is never zero during the flight of the ball? So if the ball is moving like that, remember in the horizontal, velocity in the horizontal remains constant. Reason, there is no acceleration in the horizontal. The velocity in the vertical decreases until it reaches zero at maximum height, at h maximum. So let's see. The horizontal component of the ball's acceleration, what is never zero? The horizontal component of the ball's acceleration in the horizontal acceleration is zero. The horizontal component of the ball velocity, because the velocity in the horizontal does not change, so it will never be zero. The vertical component of the ball's momentum, because at the highest point v is zero, momentum can become zero in the vertical. The vertical component of the ball's velocity, of course, the vertical component reaches zero at the highest point, so the answer is B. The graph shows the variation with the time t of the displacement s of an object. Which graph represents the variation with the time t of the acceleration a of the object? So this is a displacement time graph, and the gradient is the velocity. The gradient of a displacement time graph is the velocity. So here we are seeing that the velocity is constant. When v is equal to a constant, because the gradient is constant, it means acceleration is zero. So here acceleration is zero, acceleration is zero, acceleration is zero, acceleration is zero. It only changes here at the peaks. When the gradient is constant, when the gradient is constant, it means the velocity is constant. And when the velocity is constant, it means the acceleration is zero. So it means we look for every part of the line where the velocity is constant, the acceleration should be along the x-axis. So this one is wrong. Here it is not zero. Here it is showing the acceleration is also not zero. So the correct answer will be D. Between every point where the velocity was constant, the acceleration is zero. So the answer is going to be D. Because this is showing between this value of time and somewhere here, the acceleration here is zero, acceleration here is zero, acceleration here is zero. Those are the points where the velocity was actually constant. Which expression defines force? We know that force is equal to the rate of change of momentum. So the answer is automatically D. A ship of mass 8.4 times 10 power 7 kilograms is approaching a harbor with a speed 16.4 meters per second. By using reverse thrust, it can maintain a constant total stopping force of 920,000 newtons. Stopping force, that means the acceleration is also constant and is negative because it is stopping. So acceleration is going to be negative of F over m, which will be negative of 920,000 divided by the mass, which is 8.4 times 10 power 7. I'll not compute that. I'll first leave it. I'll substitute it directly. So how long will it take to stop? So I'll use just an equation of motion because acceleration is constant since the force was constant. So I'll use V is equal to U plus AT. A ship is approaching a harbor with that speed. By using reverse thrust, it can maintain a constant total stopping force. How long does it take to stop? So it means final velocity is zero. So I'll say zero is equal to the initial velocity, which is 16.4. Where there is acceleration, I'll put negative 920,000 divided by 8.4 times 10 power 7, then times t. So I'll make it the subject. I'll just put this in the calculator. On the left hand side, let's say I have 16.4 times what is in the denominator, 8.4 exponent 7. Then I divide by 920,000, which gives me T as So T is 1497. T is 1497 point around 4 seconds. The answers given here we have in meters. We don't have 1497.4 in seconds. So let's check the minutes. So T is going to be, we change from seconds to minutes. We divide by 60. 1497.4 divided by 60 to change this to minutes. So I'll just divide this by 60. Oh, it is giving us 24.956, which is approximately 25 minutes. So our answer is going to be C. The velocity time graphs of 4 different objects are shown. Which graph represents an object falling from rest? Falling from rest. That means initial velocity should be 0. Falling from rest. So eliminate B. A long distance in the Earth's atmosphere. If it is in the Earth's atmosphere, there is air resistance. So there is force due to air resistance. And that means if there is force due to air resistance increases as speed increases. As the speed of the falling object increases, the force due to air resistance increases, which means the resultant force F, which is equal to the weight minus the force due to air resistance, this value here becomes smaller. Since the weight does not change but the force due to air resistance increases, this value W minus force due to air becomes smaller. Remember, F is MA. So MA is equal to weight minus F due to air resistance, which means since this becomes smaller, M is constant, it means the acceleration decreases. A is showing a constant acceleration, which is not true. C is showing that acceleration increases because C is showing increasing gradient, and this is also not true. The acceleration, we are seeing that when this difference becomes small, it means the acceleration is decreasing because acceleration is directly proportional to that difference. So it means the answer is going to be D, which has a decreasing gradient, showing a decrease in acceleration. Number 10. Which statement about collisions is correct? Remember, for all collisions, momentum is conserved. But for inelastic collision, kinetic energy is not conserved. That means for inelastic, relative speed of approach is not the same as relative speed of separation. But for elastic, relative speed of approach should be the same as relative speed of separation. So let's check. Kinetic energy is conserved in all collisions. This is not true for inelastic. Momentum is only conserved in perfectly elastic collisions. Not true. In all collisions, momentum is always conserved. That's why we say the total momentum of an isolated system of interacting bodies is always constant. The principle of conservation of momentum. The relative speed of approach is equal to the relative speed of separation for a perfectly elastic collision. That is true. So our answer is going to be C. When two objects of different masses collide, they exert forces of different magnitudes. That is not true. Newton's law, third law, also applies. The force is equal but opposite. A satellite uses two thrusters to adjust its motion in space. Each thruster exerts a force of 40 newtons on the satellite. The line of action of each force is a perpendicular distance of 2.3 meters from the center of gravity. So that means the distance between the two forces is going to be 2 times 2.3 meters. Okay, what are the magnitudes of the torque and the resultant force? Of course, these two forces are equal but opposite. The resultant force must be 0. So we eliminate B and D. Then let's check the resultant torque. The torque is equal to the force times the perpendicular distance between the two forces. One of the forces times perpendicular distance between the two forces. That is moment of a couple, because these two forces are constituting what we call a couple. So the torque is going to be force, one of the forces, which is 40 times the perpendicular distance between the two forces, which is 2 times 2.3. So we check with the calculator. 40 times 2 times 2.3. This is giving us 184. which is approximately 180 to 2 significant figures. So our answer is going to be C. The diagrams show two ways of hanging the same picture. In both cases, a string is attached to the same points on the picture and looped symmetrically over a nail in a wall. The forces shown are those that act on the nail. In diagram 1, the string loop is shorter than in diagram 2. Which information about the magnitude of the forces is correct? So let's check. Of course, R1 and R2 must be equal. For equilibrium, these are equal. But if they are equal, then T1 and T2 cannot be equal because the strings are not of the same length. Therefore, the angle here, if I look this angle here, let me call this one theta 1. And this angle here, I'll call this one theta 2. You notice that theta 1 is greater than theta 2. And if I was to check R1 would be equal to T1 and T2. The T1s here are identical. The angle between them is the same. So R1 is going to be twice T1. When I resolve vertically downwards, it is cos theta 1. Then the R2, the other side, is also twice T2 cos theta 2. But I want you to notice that theta 1 is greater than theta 2. Theta 1 is greater than theta 2. Theta 1 is greater than theta 2. And if theta 1 is greater than theta 2, remember the cos of 90 is 0, yet the cos of 0 is 1. That means as theta increases, the cos of theta becomes smaller. So it means cos theta 1 is less than cos of theta 2. So if R1 is equal to R2, and yet cos theta 1 is less than cos theta 2, the only way they can be equal is when T1 is greater than T2. If R1 is equal to R2, and yet cos theta 1 is less than cos theta 2, the only way R1 can be equal to R2 is when T1 is greater than T2 to compensate for the smaller cos theta 1. So if I see that R1 is equal to R2, then it is only because T1 is greater than T2. Let's check. It is not possible for R1 to be equal to R2 when T1 and T2 are equal, yet the string has a different length. So that is out. If R1 is equal to R2, then T1 is greater than T2. That one makes sense. So this one will not make sense. T1 will not be. If R1 is greater than R2, then T1 is less than T2. Let's check. Remember cos theta 1 is less than cos theta 2. If we say R1 is greater than R2, then that is only possible if T1 is greater than T2, not less. So this one is not going to be true. Then R1 is less than R2, T1 is equal to T2. That one is not true. So our answer is equal to B. We have seen when you look at the two equations, remember we resolve T1 downwards and there are two. That's why you see these two coming into place. These two angles are identical. That's why I said 2T1 cos theta 1 and 2T2 cos theta 2. But remember cos theta 1 is going to be less than cos theta 2 because theta 1 is greater than theta 2. Therefore, if R1 is equal to R2, then it is only possible when T1 is greater than T2 to compensate for the smaller value of cos theta 1. Okay, I think I've laid so much on that. An object shaped as a hemisphere rests with its flat surface on a table. The object has radius r and density rho. The volume of a sphere is 4/3 pi r cubed, which average pressure does the object exert on the table? So, of course, it is a hemisphere. Maybe I can draw, this say the circular base, and we put in on the hemisphere like this. Hemisphere is half a sphere, so it is something like that. So it means the base is the circular area. So the pressure is going to be force over the area, which area is circular. The force is going to be the weight, which is m times g, over the area, which is going to be pi times r squared. Then the mass is density times volume, then times g over pi r squared. Now we are substituting for the volume. The volume of a sphere is 4 over 3 pi r cubed. That means the volume of a hemisphere is a half of that. So this will be density times a half of the volume of a sphere, which is 4 over 3 pi r cubed. This is the volume of a hemisphere. Then times g divided by pi r squared. So you notice that actually pi cancels out, and then r squared reduces this one to just r. A half reduces this one to 2. So you remain with the density times 2 over 3 r times g. So in other words, our answer is going to be 2 over 3 density times r times g, which makes our answer to be automatically D. A probe is used to monitor the quality of the water in the sea. The probe is suspended by a vertical string which is attached to a sphere. The stationary sphere floats in equilibrium on the surface of the sea as shown. So we have the weight of the sphere downwards is 5 newtons, and then the weight of the string and the probe is also downwards, which is 2 newtons. But remember, it is in equilibrium. That means there's another force balancing it upwards. Okay. The up thrust acting on the probe and the thread is negligible, but remember it is floating. Therefore, the weight of these two, the probe and the sphere, must be equal to the weight of the liquid which they can displace, and this can be equal to density of the mass times g. So the total weight is 5 plus 2, which is 5 plus 2, that is total weight. The mass is density times volume times g. So we have that 7 is equal to the density, which is 1.03 times 10 power 3. This is the density. Then times the volume. G is 9.81. So I'll just check this with my calculator, making you the subject. So I'll say 7 divided by open brackets and 9.81 times 1.03 exponent 3. So this is giving me 6.93. So V is 6.93 times 10 power negative 4 meters. Is it in meters? Yes, meters cubed. So let's check. So our answer is going to be D. What is the center of gravity of an object? Center of gravity. Center of gravity. Of course, center of gravity is a point on an object. It may not even be on an object, but it's a point where the entire weight of an object is always considered to be acting or seems to be acting. So our answer is automatically B. The point at which the weight of a body may be considered to act. That is the center of gravity. A system with an efficiency of 74% wastes 230 watts of power. Let's see what fraction is wasted. So the fraction wasted or percentage wasted is equal to 100 minus 74, which is, I think that is 26%. So it means 26% of the input power of input is wasted. 26% of the input power is wasted, so I will simply say 26 over 100 times power input is equal to what is wasted, which is 230. So let's check power input. The power input is going to be 230 times, I'm cross multiplying, 100 divided by 26. So the power input is 884. So power input is 884.6 watts. That is power input. Note that we want the power output. This is the power wasted. So power output is equal to the power input minus the power wasted. So this will be 884.6 minus the power wasted, which is 230. So that one I'll just say minus 230. That is 654.6, which is approximately 650. So our answer is automatically C. A projectile of mass 0.25 kilograms is at a height 30 meters above the horizontal ground and traveling at a speed of 15 meters per second. A short time later, it is at a height of 35 meters. So there has been a change in height. The change in height is simply 35 minus 30, which is 5 meters. That means the change in gravitational potential energy, I will just write as change in MP, is mg times change in the height h. Okay, how much work is done against air resistance during this time? Note that when there is a change in height above the horizontal ground and it's traveling at a speed of 5 meters per second when it is at 35 meters. So the speed has decreased, there is loss in kinetic energy. Therefore, the loss in kinetic energy is equal to the gain in potential energy plus the work done against air resistance. The work done against air resistance or friction. Let me just call it FR. So I want to find the work done against air resistance. The loss in kinetic energy is going to be a half times m into v squared minus u squared. I'm using kinetic energy. Should be equal to mg times the gain in height plus the work done that we want. So the work done is going to be equal to a half, which is 0.5, times the mass, which is 0.25, then times change in velocity squared, that will be 15 squared minus 5 squared. Then I subtract mgh. So this will be m, which is 0.25, times g, which is 9.81, times change in height, which is 5 meters. So let's check. 0.5 times 0.25 times, open brackets, 15 squared minus 5 squared. Then I subtract, open brackets, 0.25 times 9.81 times 5. So that gives us 12.7375, which is approximately 13. So the work done is approximately 13 joules. So the answer is going to be B. A spring has an unstretched length of 4.5 centimeters. The spring is fixed at one end and a force of 35 newtons is applied to the other end so that the spring extends. The spring obeys Hooke's law. If it obeys Hooke's law, we can get the extension from Hooke's law. Force is equal to kx. So it implies that the extension is going to be F, which is 35, over over the constant, which is 420. That is the extension. So we want to find the strain of the extended spring. Remember, strain is equal to extension over original length. So the extension is 35 over 420, then divide by the original length, which is 4.5, but it was in centimeters. So I'll simply say times 10 power negative 2. So let's find the answer here. 35 divided by 420, then again divide by 4.5 exponent negative 2. So this is giving us 1.851 recurring, which is approximately 1.85. So our answer is going to be C. The wire is fixed at one end and extended by a force that is applied to the other end. The force is slowly increased from 0 and then slowly decreased back to 0. You notice that when it is slowly increased from 0, this is the shape, and when it is slowly removed, we pass through via the same original path and it will go back to the original length. So in other words, all the extension is removed. That means elastic. This is only elastic. If there was some extension retained, we would have plastic deformation, but this is only elastic. So let's see the answers here. The graph line for the wire being loaded is the same as the graph line for the wire being unloaded. So it means this is only elastic deformation. Which statement describes the deformation of the wire? And I've said it is only elastic. If it was both elastic and plastic, when the deforming force is removed, there will be an extension remaining. If it was plastic only, then we just know when the deforming force is removed, all the length which has been the wire will just go back, it will just retain the whole new extension. Okay. In a progressive water wave, two particles P and Q on the surface of the water are a fixed horizontal distance apart. P and Q oscillate vertically. They oscillate vertically. At time t equals to 0, the wave is seen here. So let's see this is the wave. Now this is a progressive wave. If particle P and Q are out of phase by a certain angle, it means they will always remain out of phase by that angle throughout. Let's see what the question wants. Which graph best represents the variation with the time t of the phase difference between the oscillation of the water particle P and the oscillation of the water particle Q? For two particles at the same at specific positions on a wave, their phase difference remains the same throughout. So this one is showing that the phase difference is varying, so this one is wrong. Here the phase difference is varying, that is also wrong. Here the phase difference is increasing, it comes from negative value, it becomes 0, then it goes to the next, changes direction, this is also wrong. So the answer is going to be D. For two particles on a progressive wave, their phase difference always remains the same. For two particles on a progressive wave, their phase difference does not change. If the frequency is remaining constant or the period is remaining constant, then their phase difference does not change. Which statement about longitudinal waves and transverse waves is not correct? Not correct. Both can be polarized. We cannot polarize longitudinal waves, so this is not correct. Both waves can form stationary waves, that is true. Both waves can transfer energy, yes. Both waves obey that equation, yes. But longitudinal waves are already having vibrations of particles in the same direction or parallel to the direction of propagation of energy. So longitudinal waves cannot be polarized. So that is not correct. An observer hears a sound wave emitted from a moving source. The observed frequency is less than the frequency of the sound emitted from the source. Remember, F naught is equal to V over V plus Vs or minus Vs times Fs. Whenever observed frequency is greater than the source, frequency of the source, then here the object is moving, the source is moving towards, or the observer is moving towards. And whenever the observed frequency is less than the frequency of the source, then this one is moving away. Either the source is moving away or the observer is moving away. What could be the reason for this? Remember, they said the observed frequency, that is F naught, is less than the frequency of the sound emitted from the source. So we are looking at F naught less than Fs. That means away. The source is moving away from the observer. That is very true. The source is moving away from the observer. If it is moving towards, the frequency would be higher. What is the approximate range of frequencies of electromagnetic radiation visible to the human eye? So visible to the human eye is between red and violet. Red is 700 nanometers. Violet is 400 nanometers. I'll only check red. Find the frequency using the equation V is equal to lambda F. So F is going to be C over lambda, where C is the speed of light. So this will be 3 times 10 power 8 divided by the wavelength, which is 700 times 10 power negative 9, which becomes 7 times 10 power negative 7 in meters. This one is meters per second. 700 nanometers is 7 times 10 power negative 7 in meters. So just check red frequency. This will be 3 exponent 8 divided by 7 exponent negative 7. So this is giving us 4.29. 4.29 times 10 power 14. 4.29 times 10 power 14. Now let's check. This one will automatically be wrong because 430 kilo cannot give us this value. 430 mega cannot give us this power 14. Giga, or we can check giga. I'll just check the last one, tera, because I know the answer is most likely tera. So I will divide this by 10 power 12 to change it to tera and see if you get that. So answer divide by 1 exponent 12. So that is 428. So this is equal to 428 terahertz, which is approximately 430 terahertz. So it means the answer is going to be D because this is not giga. A beam of vertically polarized light is incident normal on a plane polarizing filter. The filter can be rotated so that it is always in a plane perpendicular to the beam. The transmission axis of the filter is initially vertical. Okay. The filter is first rotated clockwise by an angle of 30 so that the transmitted light waves have intensity I30. So let me find I30. Remember Morse's law, intensity transmitted is equal to I0 cos squared theta. So I30 is going to be I0 cos squared of 30. Okay. The filter is then rotated clockwise by a further angle of 30 degrees. So that means the new intensity is going to be I0 cos squared. Now the angle is 30 plus 30, which becomes 60. Cos squared is 60. So I want to find this value of I here, the new value of I. So what do? I will just divide the two equations. I will say I divided by I30 is going to be I0 cos squared 60 divided by I0 cos squared 30. So I'll check the calculator. So cos squared 30, cos 60 squared cos squared 60 is that one, divide by cos 30. Here I have to put two brackets. Cos, you first get cos 30. Okay, cos of this is good. I note has cancelled. So the cos of 60, because I know some people are doing PCB, cos 60, cos 60. I get my answer, then I square. It is a quarter, which is 0.25. So this is 0.25 divided by cos of 30. Cos of 30, then I square, it is 0.75. Now I divide. So 0.25 divided by 0.75, it gives you 0.3 recurring. So I is going to be 0.33 recurring times I30. So the answer is going to be B. A musical instrument is made using a long tube with a mouthpiece at one end. The other end is open and flared as shown. So it is going to behave like a closed pipe. A musician maintains stationary sound waves with a node at the mouthpiece. So there is a node here and an antinode at the other end. So it is behaving like a closed pipe. The moment I identify that it is a closed pipe, I know that the harmonics of frequencies Fn is going to be n times F naught, but remember n is going to be an odd number. For a closed pipe, n is an odd number. So for the first one, fundamental, first harmonic is equal to F naught, which is equal to 92. It is given as 92. The lowest frequency of the sound that the instrument can produce is 92. So F naught is 92 hertz. The next odd number is going to be F3. So F3 will be equal to 3 times F naught. 3 times F naught, I think this is 276. The next one will be F5. F5 is 5 times 92. We are just taking odd numbers. N is 1, 3, 5, 7, 9, and so on and so forth. So 5 times 92, I think this is 460. Yeah, that is 460. So without even checking the next one, I think the answer is going to be C. So these two were out. Then I checked the third one here, and I think the answer is C. You can check 5 times 92. I think is 460. Two waves of equal frequency and amplitude are traveling in opposite directions along a stretched string. When they meet, they form a stationary wave with 3 nodes and 2 antinodes. I can sketch that. They are forming something like this. So their frequency is equivalent to 1 complete cycle. It is giving us just 1 complete cycle. This is a node, a node, a node, an antinode, an antinode. The frequency of both waves is doubled. We notice that frequency is directly proportional to the number of antinodes. Of course, if the frequency is doubled, I can predict that the number of antinodes has also been doubled. Or we can even sketch. A frequency which is double the one which I have just sketched will have 4 loops. So we have something like this. That is double. So we have 1, 2, 3, 4 antinodes. So our answer is automatically D. How many antinodes are there in the new stationary wave? So the answer is automatically D without even much reasoning. A transmitting mast sends out microwaves of wavelength 1.5 centimeters and radio waves of wavelength 1.5 kilometers. Note that the radio waves have a longer wavelength, so they can easily undergo diffraction around an obstacle as compared to the microwaves. So a receiving area behind a mountain can detect radio waves but not microwaves, simply because radio waves can undergo diffraction easily compared to microwaves which majorly travel in a straight line. What is the reason for this? The radio waves are coherent, but the microwaves are not. That is not the reason. I said radio waves undergo diffraction easily because of the longer wavelength. The radio waves are diffracted around the mountain, but the microwaves are not. So the answer is B. Waves are emitted from 2 coherent sources. Which statement about the waves must be correct? Remember, the word coherence means maintaining a constant phase difference. So if they are coherent sources, they must be maintaining a constant phase difference. Which statement about the waves must be correct? They are in phase, they are transverse, they have a constant phase difference. So the answer is C. The diagram shows a screen that is a distance L from a diffraction grating. The grating has a total number of N lines. Any 2 adjacent lines are a distance D apart. So this is the slit separation. A beam of parallel light of wavelength lambda is incident normally on the grating. Which quantities are affected? Which quantities affect the distance between the first order diffraction maxima on the screen? Remember, for a diffraction grating, N lambda is equal to D sine theta. N lambda is equal to D sine theta. Okay, so D is the slit separation. So when we change the slit separation, of course, which quantities affect the distance between the first order diffraction maxima? So we want the distance here on the screen. Of course, when I change D, remember that distance is depending on this angle. So because N is constant, wavelength is automatically changing, is automatically affecting. So it means we eliminate C because C is saying wavelength is not affecting. Then, of course, D is also going to affect. So we eliminate part D because it is saying small d is not affected. So we remain with A and B. And of course, when we move the screen further, this distance on the screen, the separation between the first, or this distance between the first order maxima becomes bigger. When we move the screen further away from the grating, they also diverge further apart. So it means L is also inclusive. And B is saying L does not affect. So it means our answer is going to be A. N will only change the intensity. If we had more lines, then we shall have more. For the same, if we have more lines, then it means we shall have just a higher intensity, but not increasing the distance or decreasing the distance between the first order maxima. So our answer is going to be A. The wire carries a current of 0.10 microamperes. The potential difference across the wire is 10 millivolts. How much energy is dissipated by the wire in a time of 10 seconds? So we know that energy is equal to power times time. Power is I times V, so it is IV times time. So this is going to be current, which is 0.10 times 10 power negative 6, then times V, which is 10 times 10 power negative 3, then times T, which is 10 seconds. So let's check. 0.1 exponent negative 6, that is micro, then times 10 exponent negative 3, that is millivolts, then times 10. So I have 1 times 10 power negative 8. 1 times 10 power negative 8. I change this to, let me check, I'll just check nano. I will divide this by 10 power negative 9 and I see what I get. So divide by 1 exponent nano negative 9, that is 10. So this is giving me 10 nano joules. So it means the answer is D. It can't be 1.0. So the answer is D. What is the definition of the potential difference across an electrical conduct? We know that potential difference is the energy converted from electrical to thermal energy per unit charge. So energy transferred per unit charge, so the answer is A. It is not per unit current, it's not per unit resistance, it's not per unit time. Energy per unit time, that is power, it's not potential difference. So it means the answer is A. Which graph represents the way the current I through a filament lamp? We know that for a filament lamp, it only lights when the temperature increases. And we know that when temperature increases, the resistance also increases. So let's first look at the equation for Ohm's law. V is equal to I times R, making I the subject. I is equal to V over R. Comparing with Y is equal to mx plus C. There is no y-intercept here. So it means on the y-axis I have I, on the x-axis I have V. It means the gradient is equal to 1 over R. But remember, for a filament lamp, as temperature increases, the resistance increases. So if the resistance increases, the gradient decreases because the gradient is inversely proportional to the resistance. So C is automatically wrong because it's a straight line showing a constant gradient. A is automatically wrong because it's showing an increasing gradient when the resistance is showing an increasing gradient, yet the resistance increases with the temperature, so the gradient must be decreasing. The graph which has a decreasing gradient is B because the graph is becoming horizontal, meaning the gradient is decreasing. D is showing an increasing gradient, so our answer is going to be B. The table shows the properties of two different wires P and Q. Wire P has cross-section of diameter D. So let me start with wire P this side. We know that resistance is equal to rho L over area, and area is equal to pi r squared, which is pi d squared over 4. So it means the resistance is going to be equal to 4 rho L over pi d squared. For P, resistance is given as R for P. Then this will be 4. Resistivity is given as rho. Length is given as L over pi. Diameter is given as d squared. That is for P. Then for Q, resistance is given as a quarter R. This should be equal to, I'm substituting this equation here, this one here, is equal to 4. Resistivity is a third of rho. Then where there is L, I put twice L. Divide by pi, where there is diameter, I don't know diameter, so I'll put x squared. I want to find x. What is the diameter of cross-section of wire Q? So I'm calling it x. So I'm just going to divide the two equations. I'll divide the first equation by the second equation. So I have R over a quarter R is equal to 4 rho L over pi d squared. Now when I divide by this equation, I will get the reciprocal. So I'll say times pi x squared divided by Um, I'll just simplify this. 4 times 2L, that is 8L times 1 over 3 rho. So some of these things cancel out. R has cancelled, 4 goes up. So I have 4 here equals to pi has cancelled and rho has cancelled. L has cancelled by 4 1 by 4 2. So in the numerator I remain with x squared over, in the denominator I have 2 over 3, then times d squared. So it means x squared is going to be equal to, I'm cross multiplying, it is going to be 4 times 2 over 3 d squared. Then I find the square root. So that is 8 over 3. Let's find root of d squared is going to be d. Then so x squared is equal to 8 over 3 d squared. So I find the square root both sides. And x will be equal to 8 divided by 3. Find the square root. So that is 1.63. So this is approximately 1.6 times d. So the answer is going to be B. A cell has a constant EMF. Variable resistor is connected between the terminals of the battery. The resistance of a variable resistor is decreased. So let's sketch something here. So this is the cell. Let me put some internal resistance, and I have a variable resistor here. Let me call it R. Remember, the EMF of a cell is equal to the terminal PD, which I'm going to call VT plus the lost volts. Which statement about the change of the cell's terminal PD is correct? Let me make terminal PD the subject. Terminal PD is going to be EMF minus the lost volts. Remember, the lost volts is equal to the current through the battery times the internal resistance. So the terminal PD is decreased because more work is done moving unit charge through the internal resistance of the cell. Of course, when the variable resistance is decreased, when R decreases, the current in the circuit increases. So the current through the battery increases, and when I increases, this quantity here, the lost volts increases. When the lost volts increases, remember EMF is constant, means the terminal PD decreases. So the answer is saying the terminal PD is decreased because more work is done moving unit charge through the internal resistance of the cell. And I'm saying the answer is A because when the current increases, it means the lost volts increases. That means more work is done in moving a charge through the internal resistance of the cell. Therefore, the answer is A. Kirchhoff's two laws for electric circuits can be derived by using conservation laws. We know the first law is charge, the second law is energy. We answered this in the topic of electricity, multiple choice questions. First law is charge, second law is energy. So it means the answer is automatically B. First law is charge, second law is energy. A battery of EMF 10 volts and internal resistance R is connected to three resistors of resistances R, 2 ohms and 15 ohms as shown. A current of 0.45 amperes is in the resistor of 2 ohms and a current of 0.48 amperes is in the resistor of resistance 15 ohms. What are the values of R and capital R? Okay. Since we know the current here and the resistance, let's find the PD in parallel here. The PD in parallel using Ohm's law, PD here is going to be equal to current times resistance, which is 0.48 times 15. So the PD in parallel is going to be equal to 0.48 times 15, which is 7.2. So the PD here is 7.2 volts. If I know the PD here, it is the same PD across across R plus 2 ohms. So 7.2 is the same as, of course, we know the current. I'm using Ohm's law, V is equal to IR. The current in this branch is 0.45 and the resistance there is R plus 2 ohms. So I can get capital R. So capital R is simply going to be 7.2 divide by 0.45, then I subtract 2, which is 14. So capital R is going to be 14 ohms. So capital R is 14 ohms. Now I'm remaining with small r. Since the EMF is 10 volts and the PD across the parallel combination is 7.2, the PD, which I'm going to call the lost volts, the PD across small r is going to be 10 minus 7.2 because energy must be conserved. Remember, EMF is equal to terminal PD plus the lost volts, that is PD across the internal resistance. So this is going to be 2.8 volts. Now I need the current here, which is the current through the battery. 0.45 is entering, so I have 0.45 plus 0.48 is also entering. 0.48 is the total current which is going through the battery. So using R is equal to V over current, that is from Ohm's law, V is IR. V is going to be 2.8 over the current through the internal resistance, which is 0.45 plus 0.48, that is 0.93. So we can now just get the answer. 2.8 divided by 0.93. This is 3.0. So this is 3.0. You could be having a simpler way of solving this. So you have 3.0 and 14. So small r is 3.0. These are wrong. Capital R is 14. So it means our answer is going to be A. A battery of negligible internal resistance is connected in series with a thermistor and a fixed resistor of resistance 12 kilo ohms as shown. The table shows the resistance of the thermistor at two different temperatures. We have 20, it is 12, 50, it is 5. The potential difference V out across the fixed resistor is 4.5 volts when the thermistor is at temperature of 20 volts. Remember the potential divider formula? V out is equal to R1 over R1 plus R2 times the voltage supply. I'll call it Vs. So when the V out is 4.5, the resistance is 12 for the fixed resistor. Total resistance is 12 plus the thermistor at 20, it is 12 also. So this is times 12 times Vs. Then, so it means 4.5 is equal to 12 over 24 times Vs. Then at 50, what is V out when the thermistor is at a temperature of 50? So now V out is equal to, at a temperature of 50, the PD is going to be R, which is 12. Total resistance is 12 plus at 50, the resistance is 5. So that is plus 5. Then this is also times Vs. So we have this equation and that equation we are just going to combine. So I'm dividing the two equations. So I'll have V out over 4.5 is equal to 12 over 17 divided by, I will say multiplication, and I get the reciprocal, 24 over 12. So 12 has cancelled. So V out is going to be 24 divided by 17 times 4.5. 24 divided by 17 times 4.5, that is 6.35. So V out is going to be 6.35 volts. So our answer is going to be C, 6.35 volts. What is the conclusion from the alpha particle scattering experiment? Remember, most of the alpha particles went straight through with little or no deflection because most of the atom is empty space. A few were deflected because most of the mass is concentrated in a small positively charged nucleus. Protons and electrons have equal but opposite charges. Protons and electrons. We cannot conclude this from the alpha particle scattering experiment. Protons have a much larger mass than electrons. We can't conclude this from alpha particle scattering experiment. The nucleus contains most of the mass of the atom. Yes, very true, because most of the atom is entirely empty space, and most of the mass is concentrated in a small positively charged nucleus. So our answer is going to be C. 39 americium 241 is a radioactive nuclide used in smoke detectors. It undergoes alpha decay. Remember, alpha is 42. It is a helium nucleus. That is 42. What are the values of A and Z? Nucleon number reduces by 4, so it is 241 minus 4, which is 237. So nucleon number is 237. So that means the answer is automatically A because the others are different. You can check proton number. It will be 95 minus 2, which will be 93. So the answer is A. And lastly, a top quark has a charge of positive 2 over 3e, where e is the elementary charge. What is the charge of an anti-top quark? Of course, if the top is positive, the anti-top is negative of the same magnitude. So the answer here is A. Okay, I think that is the end of this paper. I tried to be faster. I wanted to use 50 minutes, but I've used 1 hour and 5 minutes. I hope this will be beneficial. Download the paper if you want. You can just practice the questions. You never know. If you have seen that many multiple choice questions have been repeated and they are almost the same as those ones that I have been solving in the past papers, in those I have been solving per topic. So I hope you have learned something from this, and I wish you all the best, great success in your exam. Bye bye.